Okay, so let us start with now our next lecture, that is on engineering mechanics. We are starting, and this particular lecture is for all the exams which we are expecting, public sector exams. So the question level is for HAL and a similar level question we are going to do. So let's start with the questions. This PDF you will get it, and try to do the questions. The level of the question is not the gate level. The level of the question is public sector level. Hindustan Aeronautical Limited and these kind of exams. So all the public sector exams, including exams which last year was their HPCL exam, this level is for that, and you should be very clear what kind of level of a particular exam is there. Let us start with the questions now. This one is the first question. Now, on the basis of this concept, forces, many times questions are asked on the basis of this concept. So there are two forces which are acting at some angle alpha. Resultant force acts at an angle theta with force P. What is the value of theta? So let me make a diagram here for you. This is the kind of diagram which we can think of getting. So let's say this particular force is P, this force is Q, this force is P, and this angle is alpha between the two. There are two forces at an angle alpha, and the resultant is acting at an angle theta with force P. So let us say this is the line of action, and this is the resultant R. Now this angle, total angle is alpha, but this angle is theta. So don't get confused between Q and theta. This is the kind of diagram we are getting. So there are two forces P and Q, and the angle between two forces is alpha. Now parallelogram theorem says, let me make small diagram here. Parallelogram theorem says, if this is alpha, then this one is also alpha, right? This one is also alpha. If this is Q force, this one is also Q. Now right angle triangle mein, this becomes Q sine of alpha, and this small part becomes Q cos of alpha. If this is Q, then Q sine alpha and Q cos alpha. Now can you tell me what is this total force? This is P plus Q cos of alpha. This total length is P plus Q cos alpha. Now he has asked you what is the value of theta. That is what he is asking you. What is the value of theta? First, let me tell you how to calculate the resultant. If you see, resultant can be R square is equal to P plus Q cos alpha, this whole square, plus Q sine alpha, this whole square. This is the relation between R and P and Q. So this total is P plus Q cos alpha, and this one is Q sine alpha. So R square, Pythagoras theorem, R square is equal to P plus Q cos alpha square. So when I open it up, this becomes R square is equal to P square plus Q square plus 2PQ cos of alpha. This is a very, very important formula between two forces or two vectors. When two vectors are at some angle alpha, then the resultant is P square plus Q square plus 2PQ cos alpha. That is a very, very important formula. Now very frequently one question is asked. इसमें से एक question वो पूछता है. Very frequently he asks you one question into this, and the question is, what if the two forces are equal? What if two forces are equal? अगर मैं P is equal to Q ले लूं, then what this formula will be? R square is equal to P square plus P square plus 2P square cos of alpha. That is a formula between R and P. If the forces are equal, this is the formula we are going to get it. Now, cos of alpha is 2 cos square alpha by 2 minus 1. Cos of alpha is 2 cos square alpha by 2 minus 1. That is what you can take. So if you put that formula here, what you get is R square is equal to 2P square plus 4P square. Then this basically will become, if you take 2P square, 2 cos square alpha minus 1, then this becomes 2P square into 2 cos square alpha by 2 minus 1. That is how you can take this particular term out. And then you can take this term 2p square common. You can take this 2p square term common. What becomes is 1 plus 2 cos square alpha by 2 minus 1. So plus 1 minus 1 gets cancelled out, and inside you get 2 cos square alpha by 2. Eventually this becomes r square. This becomes r square is equal to 4p square. This is 4p square cos square alpha by 2, or r is equal to 2p cos of alpha by 2. This is a very, very important relation from where question comes in the exam. So for public sector exams, question comes from this concept. So listen carefully whatever we have done so far. We have taken the basically vector addition of the vector addition of two vectors p and q, which are at some angle alpha. What is the resultant is p square plus q square plus 2pq cos alpha. Alpha is the angle, included angle between these two vectors p and q. Now if p is equal to q, if you keep on solving, then resultant will become 2p cos alpha by 2. These two formulas are very, very important. But the question he has asked you, question is to find out this theta. Now can you tell me what is tangent theta? Tangent theta is equal to, go to this diagram, tangent theta is equal to q sine alpha, which is perpendicular, over p plus q cos of alpha. P plus q cos of alpha, right? And you have to find out the theta. So theta is equal to tangent inverse q sine alpha over p plus q cos alpha. So answer, as you have rightly given, this is the answer for this particular question. Now on the basis of this small concept, many times he asks you the question in the exam that if the two vectors, if alpha, what can be the maximum value of the this resultant, what can be the minimum value of this resultant. Now think of if alpha is 0 degree. If alpha is 0 degree, cos 0 is equal to 1. And then if alpha is 0, that means both the vectors are in the same line. So what we get is r square, r is equal to p plus q. Simply you will get it. If both the vectors are opposite, r is equal to p minus q. If both the vectors are at an angle 90 degree, r square is equal to p square plus q square. So these are the three formulas we have. So r is equal to p plus q if alpha is 0. R is equal to p minus q if alpha is 180 degree opposite. And r square is equal to p square plus q square if the angle is 90 degree. But for any other angle alpha, this is the formula we have got. So this formula is important, and as you know, the angle also you can calculate, and this formula is important if the two vectors are equal. So this is how it is to be done. So remember this particular thing, and this is important concept for us. That is how we will understand this. Okay, so let's go for next question now. Next question is this Lemmy's theorem. Lemmy's theorem may many times he asks you a question about Lemmy's theorem. So what is the answer to this? What answer will you give for this? Lemmy's theorem is applicable only for what? Which kind of forces is this? So Lemmy's theorem is basically used for coplanar and concurrent forces. Coplanar means there should be in the same plane, two-dimensional, and concurrent means acting at the same point. So concurrent means acting at the same point. And number 3, this is the equilibrium theorem for three forces. So there are three forces involved. It is the equilibrium theorem. And what is the meaning of this? That means if I give you three forces acting at a point, and such that, let us say this is F1, F2, F3, let us say these are the three forces acting at a point, and these forces are in the same plane, and suppose the body is in equilibrium. Now let me give you the angle. This is, let us say, alpha, this is beta, and this is gamma. Then Lemmy's theorem says the body will be in equilibrium if F1 over sine of alpha is equal to F2 over sine of beta is equal to F3 over sine of gamma. This is what the Lemmy's theorem is, and you can expect questions from Lemmy's theorem. So this is what the Lami's theorem is. This is how this question comes. And now let me tell you, sometime he will not give you this diagram. He will not give you this diagram. He will give you diagram of this type. There's a force acting F1, there's a force acting F2, and there's a force acting F3. Right? So he will give you this kind of diagram. And we need to now, from this diagram, we need to make this F2, F3, and this is F1. So you need to make this particular diagram, and then you need to solve it. So you need to convert the diagram. You need to make this diagram into something another form, convert the diagram into another form, and then you need to solve it. हम इसका क्वेश्चन भी करेंगे, लेकिन Lami's theorem is basically the theorem for equilibrium of three forces which are concurrent and coplanar. Equilibrium of three forces which is concurrent and coplanar, उसको याद रख लेना. ये थ्योरम क्या है, इसको याद रख लेना है. एंड अगर ऐसा डायग्राम दिया है, if the diagram is of this type, you are to make this diagram and then proceed forward. That is what the Lami's theorem is all about. Okay, so I think this we did. Now let's go to next question. This is the next question. If two of the three concurrent forces in equilibrium have equal magnitude P and angle is alpha between them, then what is the magnitude of the third force? That is a question. Now listen to this. This is a very simple question. He's saying there are three concurrent forces acting in the equilibrium. Let me give you two forces, P and Q. Can you give me the resultant of these two forces? Their resultant is R. Let us say the resultant is R. If the third force is also equal to R, this R and this R will be balanced. If the third force is also equal to R, then the body will be in the equilibrium. So if the two forces P and Q, which are having angle alpha, if the resultant of these two forces R is equal to the third force, then the body will be in equilibrium. So basically, he has given you, how do you calculate R? R is P square plus Q square plus 2PQ cos of alpha. Right? And now he has given that two forces are equal. That means it is P square plus 2P square cos of alpha. I take 2P square common. This becomes then 2P square taken common, 2 times cos square alpha by 2, that is coming out. So 4P square cos square alpha by 2, that is R square. Just now we did. So what is now resultant? That is 2P cos of alpha by 2. 2P cos of alpha by 2. That is the answer for this. Right? That is what we did just now. That was the question we just now did. तो आपको इस तरीके से वो अलग अलग क्वेश्चन बनाने को, फ्रेम करने को दे सकता है इस कंसेप्ट के ऊपर. सो रिमेंबर दिस कंसेप्ट एंड द बेस्ट वे टू प्रिपेयर फॉर एनी कॉम्पिटिटिव एग्जाम इज कि जो कंसेप्ट तुम कर रहे हो उसको अच्छे तरीके से याद कर लो. जस्ट रिवाइज द कंसेप्ट, जस्ट डू द कंसेप्ट नाइसली, वट एवर यू आर डूइंग. Then you can solve the questions related to that concept. You can solve those questions which are related to those concepts. That is all we have to do it. Let's go to next question now. This is the next question. You are to find out the resisting torque for static equilibrium in the following figure. So you need to tell what is the static equilibrium resisting torque. What will be the resisting torque for static equilibrium? So there is a resisting torque. This is the resisting torque. We have to find out what will be this resisting torque. So how much is this torque tau acting? And can you see this diagram? So let me make this diagram once again for you. So this is the kind of force which is acting, 20 Newton, right? So what is the resisting torque? First we need to see what is the torque acting on the body. So this one is 30 centimeter, length is given 30 centimeter. Can you tell me how much is this force? Okay, now this angle is 30 degree. So if this angle is 30, can you tell me what is this angle? This is also 30. That means this is F cos theta. This is F cos 30. This is F sin 30. So what is the torque associated with this particular force? This F cos theta is not producing any torque because it is passing through the hinge point. It is not producing any torque, but the torque produced is equal to F sine 30 into X, or 30 centimeter. So sine 30 is 1 by 2. So that is 15 into F. So if we take care of the force which is given to us, the force which is given is 20 Newton. 20 into 15 is 300 Newton centimeter. So force is in Newton and the distance given is in centimeter. So this is 300 Newton centimeter is the force which is provided to us. Right, that is how this question we can find out. Okay, so all these questions which we have taken are either from objective engineering services or previous year public sector questions. So let's try to solve this question one by one. Force applied on body of mass 100 kilogram to produce an acceleration of this. Very simple question, but these kind of questions are normally asked in the exam. So F is equal to ma, F is equal to m into a. So that is nothing but it equal to 500 Newton. F is equal to ma. So that is very simple question, but this was asked in one of the public sectors. So you should be very clear what kind of questions are asked. Now let's go for next question now, and we may use Lemmy's theorem here. Now two identical trusses supported a load of 100 Newton as shown, and length of each truss is 0.1, cross section is this, Young's modulus is this. You have to find out the force in truss AC. How to find out the force in truss AC? Okay, so let's see. Let's try to use the Lemmy's theorem. We will use for Lemmy's theorem here. Find out the force. Let us say this is the force F, and because of symmetry, this force is also F. Any idea about this angle? This angle is 60. So this is 120. Right? This angle is 120. And any idea about what is this angle? This is 120. Right? This one is also 120. So can I use Lemmy's theorem now? This is 100 Newton over sine of 120 is equal to F over sine of 120. Right? So this is the answer for this question. So how much you are getting? If you solve this further, you get 100 Newton is the answer for this question. So you can use Lemmy's theorem and you can solve this particular thing. And how do you find the stress induced in any of the members? How do you find the stress which is induced in any one of the member? The stress induced in any one of the member is nothing but that is equal to the force induced per unit cross section area. That is the stress which is induced in any of the member. And suppose he asks you what is the deformation produced in any member. What is the deformation produced in any one member? So stress induced and the Young's modulus is given to you. So you can find out the strain, and the length is also given to you. This is 0.1, and if length is given, deflection can also be calculated in particular member. So this is how you can solve this question further. Okay, so let's go for question number 7 now. Two parallel forces 100 kilonewton and 75 kilonewton act on a body and have resultant of 25 kilonewton. So what are these two forces? How these two forces are connected? Can you give any idea? So there are two parallel forces. Which are 100 kilonewton and 75 kilonewton. The resultant is 25 kilonewton. So what you can tell about these two forces? Are they like or unlike? Right? If they are parallel, that means angle between these two forces is 0 degree. So resultant is P square plus Q square plus 2PQ cos of alpha. Cos of alpha is 1 because they are parallel forces. So it can be like, it can be unlike. Parallel means it can be like this or it can be like this. Now we know if they are like this, then they are simply added, and this particular value will become P plus Q. But it is not 175. If they are opposite, then 100 minus 75, this becomes this. So they are unlike parallel forces. Unlike parallel forces. That is the meaning of it. Unlike parallel forces. Okay, let's go for next question now. Horizontal and vertical components of the force acting on a body at an angle of 30 degree with the horizontal is. So I think this is very, very simple. Components of the forces you have to calculate. So if the force is given to you and some angle is given to you, so this is the force, this is F cos of alpha and this is F sin of alpha. That is what he is asking. So if there is a force of 200 Newton acting on body at 30 degree, what are the components, horizontal and vertical component? Horizontal component is F cos of 30 degree. So this is nothing but 200 root of 3 by 2 and this is 100 Newton. So horizontal component is 100 root 3 and vertical component is 100 Newton. These are the two values which we have got. So answer for this is A. These are the components for these two forces. Right? So again, very, very simple question. Let's go for next question now. Okay, so now this question, please find out now. I have two questions to ask you. There is a truss which is thrust, some link is given like this and the force 1 kilonewton is acting at 60 degree. You have to find out what is the thrust acting at point A. Number one, what is the thrust acting at point A? What is the thrust acting at point A? Number one. And what is the moment? If you can find out what is the moment and what is the thrust acting at point A. Moment and thrust. Find out what is the total moment acting at A and what is the thrust acting at A. So the moment you calculate the two components of this, one component is, this is cos 60 degree, so half of kilonewton, and then this is the another component which is root 3 by 2. So this comes out to be 30 root 3 kilonewton. So this is basically 1 kilonewton into root 3 by 2, sorry. So that comes out to be, 0.5 into root 3. So these are the two forces which we have. Now you see this component is not going to produce any thrust. This component is not going to produce any thrust, but yes, this component is going to produce thrust force acting at point A. How much is that thrust force it is going to produce is this one. This is 1.732. So it comes out to be 0.866 Newton. That is answer. That is a thrust force it is producing. But what is the movement? Any idea what is the movement this force produces at this point? What is the movement this force is going to produce at this point? You cannot find this movement unless until I give you some dimensions. Let us say this is x, this is y. Now tell me what is the movement this produce on the point A. So the movement produced by this component, which is 0.866, the movement produced by component 0.866 into x, and that is clockwise, similarly 0.5 into y. This is the total movement produced by this force on the point A. On point A. So the question can be asked, what is the movement produced at point A by the forces? Not thrust, but movement produced at point A. This is how you can find out what is the movement produced at this particular point. Yeah, let's go for next question now. A roller of weight W is to be rolled over a wooden block as shown in the diagram. The pull force F required to just cause the motion. So how much is the pull force you need to produce? So pull force F required to just cause the said motion. How much will be the motion because of this force F? Tell me how to find the solution to this question. Now what are the forces acting on this particular point? Now see this carefully. The weight is acting downward, W. This is the resistance force acting on the body. Let's call it R. And then this is the force F. Let's use the Lemmy's theorem now. Now there are three forces. This is F. This is the resistance force. And this is the weight. So the angle, this is 90 degree, as you can see, and this is 30 degree now. So if this is 30 degree and this is one line, so that is 180 degree, this left is 150 degree. So this angle is 150 degree, right? And this, the left is 120 degree, 120 degree. Now we want to find out force F, and the given force is W. So let's write the equation in F and W. So W over sine of 150 is equal to F over sine of 120. And you know, sine of 150 is sine of 90 plus 60, which is cos 60. And cos 60 is nothing but 1 by 2. Similarly, sine of 120 is sine of 90 plus 30, which is nothing but cos 30, which further is equal to, this is root 3 by 2. Root 3 by 2. So if you solve it, what I get here is W by 2, that is 2W, is 2F over root 3. So 2 gets cancelled out, then F is root 3 into W. Root 3 into W. That is how you can solve this particular question. So again, this question was asked in, I think, engineering services. That was the engineering services, somewhere else this question was asked. A simple question, you can solve this, right? So this was a good question, right? Now let's go for next question here, and the next question is also related to this kind of balance. So there's a 40 millimeter dia water jet which strikes a hinged vertical plate of 800 Newton normally at its surface and at its center of gravity as shown here. What will be the angle of deflection? That is what the question is. So what will be the angle of deflection for this? What will be the angle of deflection? Angle of deflection is asking about theta as shown in this. So there is a plate which is vertical. So initially there is a plate like this, and then, you know, if I make a diagram, there is a plate like this, and this is the center of gravity of the plate, and there is a liquid jet which applies a force on this particular plate. Now in the equilibrium state, what happens? In the equilibrium state, this is the diagram which we get. This is G, and this is, let us say, angle theta. This is what we get. Now we need to find out. So entire weight 800 Newton is acting at G point, right? And the force is acting F this side. This is the force which is acting, and this force is applied on this particular plate. You have to find out the angle theta. You are to find out angle theta. Okay, now let's consider the equilibrium of this point. The equilibrium at this point. So net movement, because it is the plate is in equilibrium now, net movement acting at this particular point will be 0. That means the movement applied by force F at this point and the force 800 Newton at this point will be equal. Both the movements will be equal. Okay, now if this angle is theta, try to understand this angle is also theta. This angle is also theta. Good. And if this angle is theta, then this angle is also theta, because this is 90 minus theta. This one is 90 minus theta. This angle is also theta. That means this is F cos of theta. See this carefully. If this angle is theta, then this angle is also theta, 800 Newton, and F cos theta is perpendicular to this length. This is perpendicular to this length. And how much is this length? Let us say the length of this entire plate is L. So this one is L by 2. So what is the moment applied here? F into L by 2 into cos of theta. That is one moment applied by this particular force, which is F. So try to understand. This F is the force which liquid jet applies on the plate at the centroid. So this F has two component. Now in this particular condition, this F has two component, एक perpendicular to the plate, that is F cos theta, and another in the direction of plate. So F cos theta produces F cos theta into L by 2. So what is L by 2? L by 2 is this particular length, because centroid is at the half point. Done. So now how much is the moment produced by 800 Newton? 800 Newton into, now which distance we have to take? We have to take this particular distance now. We have to take this distance now. How much is this distance? Let me give you the diagram. This one is L by 2 and we are finding distance x. This angle is theta. Can you tell me what is x in terms of L by 2 now? What is x in terms of L by 2? We want to find out this distance x, because 800 into x is the clockwise movement, F cos theta into L by 2 cos theta is the counterclockwise movement. What is x now? If I'm not wrong, this is L by 2 cos theta. L by 2 cos of theta. Just check it out whether it is coming. L by 2 cos of theta. So how much you are getting? Are you getting something similar to this value or something else? Just check it out. So if you see this value, this is L by 2. So cos of theta is x over L by 2. So x is L by 2 into cos of theta. L by 2 cos of theta. This gets cancelled out. So F should be 800. Is this what we are going to find is angle of deflection? I think we want to find out theta, not equilibrium, but we want to find out angle of theta. So let me see whether we are getting this value or not. Why we are not getting this value? Okay, so I think there is some kind of angle here. This is F into cos theta. This angle is theta. So let's see whether it is coming 90 minus theta. This is also theta, and this W is also okay. I made a mistake here. This angle is not theta. This angle is not theta. This is 90 minus theta, and that is the reason this is coming out to be sine theta. So this one is L by 2 sine theta. So L by 2 gets cancelled out. Now this, this becomes out sine theta, tan theta. Tan theta is F over 800. F over 800. That is the value which we are getting. F over 800. And now what is the force F acting on this particular what is the force acting, because we are given the diameter and we are given the velocity. So what is the force which this jet is applying? So what force this jet is applying, that we can calculate, and that force which jet is applying is basically from the fluid mechanics rho A into V square. Density is 1000, A is pi by 4 into D square. 0.04 square pi d square by 4 into V, that is 15 square. That is the force which this jet is applying. That is the force which it is applying. Right? So see this carefully now what we have done. F cos theta is one force which is L by 2. F into L by 2 cos theta, that is one moment. And this 800 Newton into X. What is X? L by 2 sin theta. L by 2 gets cancelled out. And this tan theta is F over 800. But what is the F? What is the force applied by this jet? That is equal to rho into A into V square. A is nothing but area of cross section. Pi by 4 into d square, area of cross section of the jet. From where this formula came? That is from the fluid mechanics now. Force impinged about by the jet, the force applied by the liquid jet on plate is a density into cross section area into velocity square. So if you put the values together of all these forces and all, then theta should come out to be, answer for this should be this, sine inverse 0.353. That is a value which we are going to get. So tangent theta, if you get, you can get the value of sine theta also. I think that is a value which we are getting here. So check it out whether it is correct for you. Are you getting this value or not? Are you getting C for this or A? What answer you are getting? What answer are you people getting? C or A? Deep Tanu is getting C for this. So check it out, this answer, and solve it. This is a really good question. Only thing is you need to basically put the values and see what value you are getting for this. So there are forces acting. One force is this, and the another force acting is weight. So weight and these two forces are in the equilibrium. Check it out, what is the force coming? Either this will come tan inverse 0.353 or it will be sine inverse 0.353. Anyway, let's go for next question now. A ball of weight, this is tied to a smooth wall by a cord making an angle 30 degree to the wall. Tension in the cord will be. So this question also is basically very frequently asked question. This is the kind of situation which is given. This is a ball. Let me make the diagram here. So there's a ball and then there's a cord which is connected to this ball, and the weight of the ball is 100 Newton and cord is making 30 degree angle. This one is 30 degree and the weight is 100 Newton. What is the tension in the cord? That is the question. So what is the tension in the cord? Right, that is what we have to find out. So what, again there are three kind of forces. One is the reaction which is acting this side, another is the tension, and third force is 100 Newton here. Okay, if this angle is 30, then this angle is also 30. This is also 30. And then what we get here is, these are the three forces: tension 120 degree, this is reaction, this is 100 Newton, this is 90 degree. These are the three forces which we are getting. We want to find out the tension. So let's calculate the formula between tension and W. So what we get here is T over sine of 90 degree is equal to W over sine of 120 degree. So T is nothing but W over sine 120. Sine 120 is sine 90 plus 30, which is cos 30. So W over cos 30, which is 2W by root 3. 2W by root 3. And what is the W given to us is 100. So 200 over root 3 Newton. That is the value which is given to us, and hence B is the answer for this. So that is the value which is given to us, 200 by root 3. Right, so this is the answer for this particular question. Let's go next. Again, this is a simple tension kind of question. Tension in the rope AC. We have to find out what is the tension in rope AC. All the angles are given to us. We want to find out tension. So calculate it fast. Tell me what is the answer coming. Let's say this is a tension T1, this is a tension T2, and 100, that's 10 kilogram weight is also given here. So what is this angle? This is 90 degree. If this is 30, this is also 30. So what we get is, T2. Let us say this is T1. This is 100 Newton. 100 Newton or 10 kilogram into 9.81. So this comes out to be 10 into 9.81 Newton. That is the force. What is the angle given now? This angle is 30 plus 90, 120. This is 90. So T1 over sine 120 is equal to 10 into 9.81. This T1 into this, and this is 10 over this angle. What is this angle? This is 120 plus 90, 210, and then 150 over sine of 150 degrees. So you know that. So what is the value of T1? That is what we want to calculate. So value of T1 in this case is coming out to be 169.91. So answer for this is C. You calculate this answer. This is C coming for this question. Right? This is what the question for this is. Okay. So let's go for next question. Try to answer this question now. Try to find this answer now. If the body is in equilibrium, then which of the following is true? There is no force acting on the body. Resultant of all forces is 0. Movement of forces about any point is not 0. Movement of forces about any point is 0, but resultant of force is not 0. If body is in equilibrium, what is the meaning of this? Okay, tell me what is the meaning of this. So actually, if the body is in equilibrium, I think these are not framed very nicely. Answer is D for that. Equilibrium means two things for us. So remember, equilibrium means net forces are 0 and net moment are also 0. Net forces are acting are 0 and net moment also acting are 0. Net force is 0, net moment is 0. That is the meaning of body is in equilibrium. Net force is 0 and net moment is also 0. That is the meaning of this particular equilibrium. So net force is 0 and net moment is also 0. When trying to turn a key into a lock, which of the following do you apply? What do you apply? Movement or couple, or what do you apply? And what is the difference between movement and couple? What do you think is the difference between movement and couple? Couple means if I apply a force F, then this distance is x, this point is A, movement acting at A is equal to F into x. That is called movement. When we say couple means two forces which are equal and opposite, separated by some distance x. Tell me what is the couple produced here. How much is the couple produced here? Tell me that. So the couple produced here is also F into x. So what is the difference between this and this situation? Movement is because of one force. Couple means there are two equal and opposite forces. And in this question, the answer for this will be couple, because whenever you are using your hand, you are applying two forces, equal and opposite. Even when you are rotating the handle of a cycle, you are applying two equal and opposite forces. So that is the meaning of couple. So couple means that for us, right? So equal and opposite forces we are applying. Movement arm. Find out when 12 kilonewton force produces a movement of 96. Tell me what is the movement arm. Again, very simple question. So I told you movement is nothing but force into distance. So it is 96 is F into x, and we want to find x. 96 by 12. How much is the value? So that is 8 for us, right? So 8 meter is the arm which we get, right? So now suppose I give you this particular force. There is a force which is acting, and how to find out movement at point A. How to find out movement at point A because of this force. तो इसके दो तरीके हैं. एक तो you take this component, let us say Fy and Fx, and the movement produced here Fy into this distance d. So the movement produced is Fy into distance d. So that all of us know. It's a very simple concept. We can find out the movement of any force in this particular way. Let me tell you all these questions which are which you people are doing. They are the questions taken from exams like HAL and similar public sector exams, including some objective questions of engineering services. So you need to practice this kind of question, and that is the reason some of you who are not very comfortable with GATE kind of syllabus, GATE pattern, and you are comfortable with this pattern, they get calls from exams like HPCL through their own exams, right? So practice these kind of questions. Dimension of angular velocity is calculated like what? So what do you mean by angular velocity? If I give you this now, let us say this is a radius, this is angular displacement, this angle is theta, right? So L is equal to R into theta, right? Angle is equal to R into theta. Now this theta is angular displacement, dl over dt is R d theta over dt. What is dl over dt? Dl over dt is nothing but velocity. What is d theta over dt? That is nothing but angular velocity omega. So क्या हो गया? V is equal to R into omega. What is the dimension of velocity? Lt minus 1. What is the dimension of R? That is L. And we want to find out dimension of omega. So what is the dimension of omega? T minus 1. So this answer is T minus 1. M0, L0, T minus 1. So radian per second. Radian per second. So per second is T minus 1. So very simple question. Let's go for next now. F is the limiting friction and Rn is the normal reaction. Coefficient of friction, how do you calculate? How do you calculate the coefficient of friction? Now this everybody knows this formulas of friction. So let me give you this body, and let us say coefficient of friction is mu and R is the normal reaction. So force of limiting friction is mu into normal reaction. So coefficient of friction is FL over R. So you are already aware of this. So F over Rn is the coefficient of limiting friction. So that is known to us. This is a very simple question here. Right, so this is a very simple question. Let's go for next question now. Coefficient of rolling resistance, how do you define this? How do you define the coefficient of rolling? How do you define the rolling resistance for this? Coefficient of rolling resistance, how do you define? It is a ratio between what? What do you mean is the ratio between what? Go for the answer of this. Yes, Rohan, please keep doing this because very simple questions come in these exams. If you must have seen the exam of HPCL, I don't know, Rohan, you appeared for HPCL exam or not, I don't know. But if you have appeared for the exam of HPCL, you'll find similar questions. So we should not increase the degree of difficulty only for the sake of increasing. You'll get very simple questions and you'll get ticklish questions also. Coefficient of rolling resistance, what is the answer for this? Coefficient of rolling resistance, ABCD. Now let me tell you how do you calculate the rolling friction. See the concept here. Let us say he has given you the weight of the roller as W. Now let us say he has given you coefficient of rolling friction as mu R. How do you find the rolling friction? Number one, rolling friction is in the direction, in the forward direction. Remember that, number one. Rolling friction is in the forward direction. Now, how do you find the rolling friction? There are two ways to find the rolling friction. Rolling friction is mu rolling into W. If the coefficient of rolling friction is given to us, if mu r is given to us, coefficient of rolling friction, then normal reaction, coefficient of rolling friction into normal reaction is the force of rolling friction, that is Fr. That is number one. So if coefficient of rolling friction is given to you, then you will find the force of rolling friction using this particular concept. And then there is another concept also. Then there is another concept by which we find the coefficient of rolling friction. Suppose this is the radius of this roller. So Fr into radius is the resisting torque. So rolling friction is torque acting over the radius. So R is the radius of this roller, T is the torque acting on this particular body, which is rotating it, torque. And how do you calculate torque? Torque is I into omega, like force is M into I into alpha. I is the moment of inertia and this is the angular acceleration. This is the angular acceleration. And what is the relation between angular acceleration? V is equal to R omega, A is equal to R alpha. So alpha is A over radius. A is the acceleration of this body. So suppose the acceleration of the roller is given. Understand this concept carefully. Suppose acceleration of this roller is given to us, then acceleration per unit radius is the angular acceleration, and angular acceleration into moment of inertia of this roller is the torque which is rotating it. Now that torque divided by radius is the rolling friction. Now in exam, the rolling friction questions is asked in two ways. There are two ways by which he will ask you question of the rolling friction. Number one, he will give you coefficient of rolling friction. If the coefficient of rolling friction mu r is given, simply multiply that coefficient of rolling friction with the normal reaction, which is weight, and you get the rolling friction. The weight is given here. That coefficient of rolling friction or rolling resistance is rolling friction or rolling resistance पर यूनिट नॉर्मल लोड विच इज द वेट. ये वाला फॉर्मूला है. लेकिन कई बार वो तुम्हें ये फॉर्मूला नहीं देता है. ही गिव्स यू द एक्सेलरेशन ऑफ द रोलर एंड ही गिव्स यू द रेडियस ऑफ द रोलर एंड ही विल आस्क यू व्हाट इज द रोलिंग फ्रिक्शन. कोएफिशिएंट ऑफ रोलिंग फ्रिक्शन इज नॉट गिवन. एंड सपोज ही गिव्स यू नाउ एक्सेलरेशन एंड ही गिव्स यू, because we know this I into alpha is A over R. Now alpha is A over R. So IA over R square. That is what we are getting. So rolling friction is IA over R square. Now note down carefully that this is rolling friction is equal to coefficient of rolling friction into W, which is I into A over R square. So what is the coefficient of rolling friction? I alpha over W R square. This is the expression which we are getting. So how to find out now coefficient of rolling friction for a roller? That is moment of inertia about this axis into the basically this particular acceleration of the roller, that is A, which is equal to now acceleration which is given to us over W R square. W is the weight. So remember this formula. This is very, very important formula here. Right? So this is A into I into divided by W R square. Remember this formula is an important formula. Coefficient of rolling friction is equal to moment of inertia into acceleration over W R square. What is I? Moment of inertia of the roller. What is A? A is the acceleration of the roller. What is W? W is the weight of the roller, and R is the radius of the roller. So using this, you can calculate coefficient of the rolling friction. Remember this particular concept carefully. Coefficient of friction is ratio of, that we have already done, normal reaction to the limiting force of friction, that already is known to us. So coefficient of friction is ratio of these terms. Very simple question. Okay, So a box of weight 100,000 Newton is placed on ground. Coefficient of friction between box and ground is this. When the box is pulled by 100 Newton force, friction force developed between box and ground at impending motion, that means at the start of motion, will be what? Solve this question. Tell me what is the answer for this. A box of weight 1000 Newton is given to us. Tell me what is the answer for this. Okay, so this is whenever a question is given to you like this. This is the question which is given to you, and let me explain the concept. This is a box of 1000 Newton. So this is the weight of the box given. Coefficient of friction is given 0.5. We are given 0.5 coefficient of friction. Box is pulled by 100 Newton horizontal force. There is a 100 Newton horizontal force. Friction force will be what? What is the friction force developed between box and ground? So first of all, what is the limiting friction? Mu into normal reaction. Mu is 0.5 into 1000. That is equal to 500 Newton. That is a coefficient of limiting friction. Do you think this is the case of limiting friction? This is the case of static friction. So if I draw a diagram, between the force of friction and the applied force, then up to this is the limiting friction. This is the case of static friction. If the force which you apply is less than the limiting friction force, then body will not move. And if body will not move, तो वो static friction का case है, and static friction is nothing but external force. Hence the friction will be 100 Newton, not 500 Newton, but only 100 Newton. So this is the case of your static friction, not a limiting friction. Okay, now let me make this question this way. Suppose the force applied is 1500 Newton. If the force applied is 1500 Newton, find the friction and find the acceleration. I change the question. The force now applied is 1500 Newton. Tell me what is the friction acting now and what is the acceleration acting now. So if I increase the force now and make it 1500 Newton, tell me the acceleration and tell me the friction force acting now. So now in this case, the friction force will be equal to 500 Newton. That is the friction force acting 500 Newton. So what is the net force acting on the body? Net force acting on the body is 1000 Newton, and this is M. So 1000 Newton is equal to M into A. Acceleration is 1000 over M. What is the mass? The weight given is 1000 Newton. Mass is 1000 over G. 1000 over G. So A will be equal to 9.81 meter per second square. So if the force acting is more than limiting friction, then they tend to provide you the, there will be acceleration acting in this particular body, and that acceleration can also be calculated using this. So you can find out the value of that acceleration. 13-meter long ladder is placed against a smooth vertical wall with its lower end 5 meters from the wall. What should be coefficient of friction between ladder and the floor so that ladder remains in equilibrium? Tell me what is the answer for this now. Find out what is the answer for this. This is engineering services question, for objective question of engineering services exam. So ladder question is very frequently asked. How to solve this question now for ladder? Okay, so let me give you the question of the ladder. A, B, 13-meter long ladder is placed against a smooth vertical wall. So wall is smooth, there is no friction, but there has to be friction between ladder and the floor. So let us say coefficient of friction is mu. 5 meter from the wall, this length is 5 meter, this is 13 meter, this one is 13 meter, and we know Pythagorean theorem. So this is 12 meter, 12 square plus 5 square is 13 square. Tell me what is the value of coefficient of friction? Yes. Let us say the weight of the ladder is W. What are the forces acting? Let's calculate that. Let us say the reaction here is RA. Let us say reaction here is RB. The normal reaction at A is RA, normal reaction at B is RB. Any other force left? Yes, the friction force at particular point B. Can you tell me the direction of the friction force which will act at B? Because this ladder will try to slide in the right direction, so the friction acting at point B will be in this direction. So let me take the free body diagram of the ladder now. Now this friction force is mu. This is mu into RB. Normal reaction at point B is RB. This force is RA. This force is RB. This force is W. So as you can see, there are two horizontal forces and two vertical forces. Vertical forces RB and W will be balancing one another. So the vertical forces will be equal. RB is equal to W. Horizontal forces will be also equal. Mu into RB is equal to RA. Mu into RB is equal to RA. We want to find out what is the value of mu. Mu is RA over RB. Mu is equal to this. Right? This is how we can find it out. So what is RB? RB is nothing but W. So RA over W. But still we have not got the value of mu. Now what we can do is we can calculate the movement of all forces at particular point. Let's take the movement of all forces about this point, let us say B point. So movement of all forces about point B has to be 0. So when we calculate the movement at point B, RB and force of friction will not come into picture. So let us say RA into, how much is this distance now? RA into 12 is equal to, now another force is W into this distance, which is 5 by 2. So we will get is RA is equal to now 5 by 24 W. 5 divided by 24 W. If I am not wrong, that is the value of RA coming. Now put the value of RA here, and what you get is mu is equal to RA, which is 5 by 24. W will get cancelled out. And when you solve it, I think the value should come out to be 0.21. So this should be the value 0.21. Right. So this is a little bit more. If it is 5 by 25, it is 0.2, but it is 5 by 24. So this one was a good question, and ladder question is a really good question. Ladder questions are really good questions. Now this is a ladder question in which friction is given at the base and weight of the ladder is given, length of the ladder is given. Now let me ask you a question in the same. Suppose I give you this question now and try to find the solution for this question. Suppose I give you this question now There is a ladder of length L. This angle is theta, and the W of weight of the ladder is W. Find the force applied at point B. Find the force P applied at point B so that the ladder is in equilibrium. So there is no friction. This is a smooth wall, smooth surface. You have to find out the force P acting at point B so that the ladder is in equilibrium. How shall you find this? Let's again take the forces RA. Let's take RB. Let's say W. Now what are the forces acting? एक तो W force is acting. This is RA. This one is P. And this one is RB. How shall you solve it now? We understand that P is equal to RA, and W is equal to RB. But we want to find out the force P in terms of theta and W. So let's calculate the moment about point B. Moment of all force about point B should be equal to 0. Let's calculate the moment about point B and equate it to 0. So the moment I do that, RA into, can you tell me how much is this length now? This length is L sin theta, and this length is L cos theta. L sin theta and L cos theta. Right? So this particular thing now, RA into L sin theta, that is balanced by W. So this is W L cos theta divided by 2. L cos theta divided by 2, because W will make a moment at this particular point. So I get from here, L gets cancelled out. RA is equal to W by 2 into cot theta. Just check it out whether it is correct. W by 2 into cot theta. And we want to find out P, which is equal to this value. So W by 2 cot theta. So ये दो question from ladder W cot theta by 2. So these two questions from ladder are good questions. So equilibrium of the ladder, या तो आपको फ्रिक्शन दे रखा है एट द बॉटम, या आपको वैल्यू दे रखा है फॉर force, and on the basis of that force we have to find the solution for this. Right? So try to solve this question now. A body of weight 50 Newton is kept on a plane inclined at angle 30 degree to horizontal, and it is in limiting equilibrium. Coefficient of friction will be what? So again now inclined body. This is a question of inclined body, friction acting on inclined body. So this is the diagram given to us. There is a body of weight 50 Newton और उसको 30 डिग्री पे हमने रखा हुआ है. So this is the 50 Newton body and it is kept at 30 degree to the horizontal. So what will be the coefficient of friction? Yes, tell me what will be the coefficient of friction. Solve it fast now. Question may look like simple, but sometimes you may make mistake while solving these questions. So let's take the components of this. This angle is theta, this is also theta. This is 50 cos of 30. Normal direction is also 50 cos of 30, and then another formula is 50 sine of 30 degrees. So these are the two forces, and now the friction will be acting on the upward direction. So friction is nothing but mu into normal direction. So mu into normal direction is 50 cos 30, and that should be balanced by 50 sine 30. So 50 gets cancelled out. Mu is tan of 30, which is 1 by root 3. Okay, now let me give you a question. Coefficient of friction is 0.1. Find the friction force acting in this case. If the coefficient of friction, in this case is 0.1, find out the friction force acting on the body. Find the answer to this. If the friction force is coefficient of friction is 0.1, what is the friction force acting on the body? Just find this question fast. Tell me what is the answer for this question now. Now see carefully. In such kind of questions, what we have to do is this. First of all, we need to find out the limiting friction. Limiting friction is 0.1 into normal reaction, which is 50 into root 3 by 2. That comes out to be 5 root 3 by 2. That is the limiting friction. Now check whether limiting friction is more than this or less than this. The force which is acting on the body, which is basically making it slide down, that is whether more than limiting friction or less than limiting friction. Now this force is 25 Newton, which is certainly more than this value, because this is nothing but this is approximately 2.5 into 1.732, which comes out to be 4 point something, I think 4.2 Newton or something like that, 4.2 Newton. But just assume that, but just understand that if this force is less than, if this force which is acting is less than this force, limiting friction, then the friction acting will be static friction. That is something which is very important. Suppose this force is coming out to be 2 Newton. I am giving you hypothetical case. Suppose this force is acting 2 Newton only, whereas this limiting friction is 4 Newton. Then this is a case of static friction. Now inclined body में one question he can frame where the friction is static friction, it is not a limiting friction. In this case, there will be acceleration also. The case which I have given you, there will be acceleration also, because this force is more than this force. But suppose this force is less than this force, then the friction acting will be equal to static friction, which is equal to external force which is applied. That is very important. Can you find out the acceleration in the previous case now? What will be the acceleration? And the acceleration of this component will be equal to net force acting 25 minus 4.2 over the mass of this body. So mass of this body is nothing but 50 over g, or approximately we can say 10. So that will be equal to, if I say 21 or 20.8 over 5, so that is 4.16 meter per second square. That is the acceleration of this particular inclined body. So you can find out the acceleration also of this particular body, right? Okay, find the answer for this. A block of mass m slides down an inclined plane. Coefficient of friction is given. What will be the velocity of block when it reaches the lowest point of the plane? Okay, so find the answer to this question now. Tell me what is the answer to this question. What will be the velocity of block when it reaches the bottom? Yes. Now the similar question you can get in the public sector exams like HAL. Tell me what is the answer to this question. A block of mass m slides down an inclined plane with coefficient of friction mu from rest as shown in the diagram. What is the velocity of the block when it reaches the lowest point? How shall you solve it? What concept shall you use it? We can use the concept of energy conservation in this. There is a concept of energy conservation. Use this concept of energy conservation. What is that concept of energy conservation? You know, it has potential energy at this point. Any idea what is the potential energy? mg into h. That entire potential energy gets converted into, let us say, here the velocity is v. What is the kinetic energy here? Half of m into v square. So do you think entire potential energy gets converted into kinetic energy? What is your view on that? Do you think entire potential energy gets converted into kinetic energy? What is your view on that? What is the conversion? Can you tell me this length? How much is this length? H. So sine theta, let's say this length is x. Sine theta is h over x. So x is h over sine theta. That is the length. Now let us say there's a friction acting on this particular body. Coefficient of friction is also given to us. So let us say friction force is F acting on this body. That is a friction force which is acting on this particular body. Let us say that is F. How much is the friction force acting on this body? We have just now calculated. So the normal is mg cos theta and friction force is mu mg cos theta. Just now we calculated the friction force acting on this is mu mg cos theta. Now this friction force multiplied this x is the friction loss. So mu mg cos theta into x is the energy loss because of friction. Energy loss due to friction. Now we need to make use of this energy concept to find out how much will be the velocity of the body. Now let's cancel out m. M is cancelled out, and let's take now this term v square on one side, multiply by 2 throughout. So v square is 2gh minus 2 mu g cos theta into x. And what is x? H over sine theta. So this comes out to be 2gh minus 2g mu cos theta over h sine theta. So cos theta by sine theta is cot theta, and we want to find out the value of. So let's take some terms common, which is g and h can be taken common. 2gh can be taken common, and I take this 2gh common. So if I take 2gh common, it comes out to be 2gh 1 minus 2gh. This comes out to be mu into cot theta. Mu into cot theta. 2gh 1 minus mu cot theta under root. So that is the answer to this particular question. Yeah. So this is entire 2gh into 1 minus mu cot theta. Right? This is how the value of velocity can be obtained for this particular question. Right? Okay, so let's go for next question now. Question number 25. What is the minimum coefficient of friction between rope and fixed shaft which will prevent the unbalanced cylinder from moving? Yes. How shall we solve this question now? What is this question? What is the minimum coefficient of friction between rope and shaft which prevents the unbalanced cylinder from moving? One side it is 3m, another side it is m given to us. Okay, now we know this one formula here. We know this particular formula, that if I give you two sides, let's say this is T1, this is T2, and what is the included angle here? So that included angle between rope is pi is the included angle. So T1 by T2 is equal to e raised to power mu into alpha. If T1 is more than T2, so we said T1 by T2 is e raised to power mu alpha, and that alpha is nothing but included angle, which in this case is pi radian. Okay, so this T1 by T2 will be equal to mu into pi. T1, T2 are tensions, right, which is given to us. So T1 is 3, T1 by T2 as given diagram 3m and m. Mass is given 3m and m. This comes out to be 3. Right, that is value is coming out to be 3. Now e raised to power mu into pi is equal to 3. Right? Take the log on both sides. So mu into pi, natural log 3. Now you need to remember certain values of natural logs. Natural log 2, natural log 3 comes out to be 1.098. 1.098 और निकालना क्या है 1.098 over pi का वैल्यू निकालना है. That is what we want to calculate. So this comes out to be 0.35. This is also a good question. Combination of your concept of theory of machine with this. So that was the question related to this. Right? So T1, T2 are the tensions, tight side, slack side, and included angle is given as alpha. So T1, T2 are the tensions, included angle is given alpha, T1 by T2 ratio you will get it, and from that ratio you can find out what is the value of mu. Okay, let's go for next question number 26. A block of 981 Newton is resting on horizontal surface. Coefficient of friction is given between block and horizontal surface. A vertical cable is attached to block and it provides the partial support. Man can pull the horizontally with a force of 100 Newton. What will be tension T in the cable if the man is just able to move the block to the right? Okay. So एक tension लगा है T on upward direction, and you have to find out what will be the tension T. This is the diagram given, and I'm very sure you can find it. ये tension T लगा हुआ है. This is the horizontal force 100 Newton, and this coefficient of friction is given as 0.2, and the block is weighing 981 Newton. Weight is 981 Newton. So find out the value of this T so that the man is in position to pull it in the horizontal direction. अभी तो देखो normal reaction is how much? Normal reaction is 981 downward, T upward. So normal reaction is 981 minus T. Normal reaction is 981 minus T. Now the friction is mu into 981 minus T, and that friction should be balanced by 100 Newton. So what is the friction force? Mu into normal reaction. What is the normal reaction? Normal reaction is nothing but 981 minus T is the normal reaction. Right? So we want to find out what is the value of T. Mu is given as 0.2, and then 981 minus T is 100 by 0.2, that is 500. So T comes out to be 481 Newton. T comes out to be 481 Newton. So that also is a question where, you know, if tension is given, it is upward, or at what value of T friction will be 0. If T becomes equal to 981, then obviously friction will become 0. So friction will be 0 if this becomes equal to 981. Right? So let's go for next question. Limiting friction depends upon what? Limiting friction depends upon which of the following parameters? It depends upon the material of the body, or it depends on the weight of the body, or it depends upon the roughness of the body, or all of these. So answer to this question is it depends upon all these values. Answer is D for this particular question. Block is resting on an inclined plane which begins to slide down the plane when angle of inclination is gradually increased to 30 degree. So what is the coefficient of friction between block and plane? There is a concept of angle of repose. Let me tell you what is angle of repose. Angle of repose is that angle at which body will start sliding down. That is called angle of repose. What is angle of repose? It is that angle at which the body will start sliding down. And when the body starts sliding down, then जो friction है आपका और external force, that is balanced. Let's say this is W, this is W cos of alpha, this is W sin of alpha, normal reaction is W cos of alpha, friction is mu into W cos of alpha. So when W sin of alpha is equal to mu W cos of alpha, that means tangent of alpha, W gets cancelled out, is equal to mu. So coefficient of friction is a tangent of alpha. And what is tangent of 30 degree? Which is 1 by root 3. So coefficient of friction is nothing but 1 by root 3. 1 by root 3. What is the value for that? 1 by root 3 is coming out to be how much? .57 or something. I think that is a value coming, right? So let's go for next question now. Okay, a force of 30 Newton is required to move a mass of 35 kg on flat surface horizontally at a constant speed. What is the coefficient of friction? Again, a very simple question. It's not a difficult question. So constant velocity means no acceleration. So V is equal to constant means acceleration is 0. That means friction force which is acting on the body is basically the external force which is acting is balanced by this force. F is equal to force of friction which is mu into mg. So what is given? 35 kg. M is given 35 kg. Acceleration due to gravity is g. Mu is coefficient of friction and 30 Newton. This one is 30 Newton. So we can easily find out what is the value of mu here. So that mu value is coming out to be 0.087. That is the answer for this question. Right? Okay, let's go for this question now. A body weight of 200 Newton is resting on rough horizontal plane and can be just moved by a force 80 Newton applied horizontally. What is the value of coefficient of friction? Again, we have already done this question. This is the external force which is acting on the body. This F is equal to mu into mg. A force of 80 Newton is applied horizontally. What is the value of coefficient of friction? There's a body, so this is given as 200 Newton. F is given 80 Newton is equal to mu into 200. So what is mu is nothing but 80 over 200. 80 over 200, that is a value of this. That is 0.4. Right? Okay, so let's go for next question. That is the 31st question for us. Try to solve this question now. Try to solve this question. And this is also the question of, I think, BHEL question. BHEL used to conduct its own exam. A steel wheel of 600 millimeter dia is rolling on a horizontal steel rail. It carries a load of 500 Newton. Coefficient of rolling friction is this. Force necessary to roll the wheel along the rail. I gave you the concept of this, how it is to be obtained. I gave you the concept how it is to be done. I told you that if coefficient of rolling friction is given to us, if the coefficient of rolling friction is given to us, mu r, and if we know the normal reaction, let's say W is given, then the friction resistance is nothing but mu r into normal reaction. So, we are given the diameter, but that is not required, and there's a load of 500 Newton. So, ये 500 आ गया, and coefficient of rolling friction is given as 0.3. I don't think there's any measure of that. 0.3, so rolling friction आ जाएगा 150 Newton. That is the answer for this. So rolling friction will be straight calculated like this, right? So that is a typical question which was asked in public sector. See, I think this is the basic level from where majority questions come in public sector. Difficulty level बहुत ज़्यादा डिग्री difficulty नहीं आएगा, लेकिन आपको concepts पता होने चाहिए. Simple questions and then he is going to give you a small ticklish question. So इन जितने हमने questions किए उसमें कुछ questions ladder वाले questions and pulley वाला question, कुछ ऐसे questions जो friction वाले थे inclined slope पे, they are the questions which are really good question for public sectors. Don't make mistakes in them. I will be pulling this session for engineering mechanics. We will be doing some 250 300 questions for engineering mechanics, covering all the topics of engineering mechanics which can be useful for us. So let me end up this session here today, and we continue with our HAL classes, and we pull next classes in that particular direction. Thank you. See you next time in the next class. Thank you.